वॉल्यूम बड़ा कर दूं. Okay. Complete focus on the board. Shall I start? Very good morning to my dear student. Welcome back. Now, as we have started LAQ section, today some more problems of integration we are going to solve, and especially when it's come to reduction formula. We are having 6 trigonometric ratios, and that we have to find the reduction formula each of one. How to find reduction formula? I have showed you for sine and for tan, and cos I give as homework, cot I give as homework. Today, we are going to do reduction formula for the secant, and cosecant is homework for you. Okay, damn sure. I'm expecting one of reduction formula this time will definitely come. So be perfect, be practice, and be represent yourself perfectly. Okay. So now today we are going to deal one of the reduction formula. Already, I think 4 we have completed with including homework. Today, 6 we will complete. Okay. So the first, let's start. Obtain the reduction formula for In is equal to integration of secant power x dx. Where n being a positive integer, a positive integer, and greater than or equal to 2, and hence deduce the value of integration of secant power phi x into dx. Okay. Very, very important. Secant, cosecant, tan, cot, sine, cos. Okay. Already we have done. Now let's see what to do and how to find this. Okay. The first, obtain the reduction formula for In is equal to integration of secant power nx dx, where n being a positive integer and greater than or equal to 2, and hence deduce the value of integration of secant power phi x into dx. This is our problem. Yeah, integration of phi x into dx we need to find. Okay. So the first thing, how to find the reduction form of integration of secant power nx dx. Look at here. Solution. Given that what is given to us? In is equal to integration of secant power nx dx. Okay. This particular term, how I am converting, observe here. Integration of secant power n minus 2x into secant square x dx. Okay. Just I have converted this term into this form. If you multiply these two, again you will get this form only. Okay. This is the first step. This is in the form of integration of u into dv. Yesterday's previous formula that we have already learned. From these two terms, I am taking let u is equal to secant power n minus 2 x. Okay. Now differentiate with respect to x. What we are getting? Du is equal to, here d by dx of x power n formula. First we have to apply, you know what is the formula of d by dx of x power n? I am writing here, d by dx of x power n is equal to nx power n minus 1. Okay. Now du is equal to d by dx of x power n. This is according to that formula. So what we are getting? N into into x power n minus 1. That is n minus 2 into x power minus 2 minus 1. Directly I am writing minus 3. Okay. Here x is nothing but secant power. Secant power n minus 3x. Okay. Here the inner derivative of secant x is nothing but secant x into tan x. D by dx of secant x is secant x into tan x. Okay. Into dx if you want. So now look at here. Secant power n minus 3x into secant x. If you multiply these two, bases are same, power should be added. So n minus 3 plus 1 is n minus 2. So this in a more proper way, I can write n minus 2 secant power n minus 2 into tan x. Okay. This is the value of du. Not value exactly, expressions. Okay. Du is equal to n minus 2 secant power n minus 2 into tan x. Okay. Next. What we are having? Next term I am taking as dv. dv is equal to secant square x. Okay. Apply integration on both sides. Integration of dv is equal to integration of secant square x into dx. What is the formula of integration of secant square x into dx? Integration of dv is v. Integration of secant square x into dx is tan x. So we got the value of v. Okay. Now we have to apply the formula. What is that formula? This is the formula. Integration of u into dv is equal to uv minus integration of v du. This is the formula that we are applying on the given function. On this we are applying. Okay. So according to the formula, according to this formula, this is in the form of u into dv. So first we have to write uv. So I can write in is equal to uv. U is what? Secant power n minus 2x. Okay. V. What is v? Tan x. Minus integration of v into du. V is tan x. Du. Du is a complete term. What is this term? N minus 2 secant power n minus 2 into n minus 2x. Right here x. Secant power n minus 2x into tan x into dx. I'm writing here. Okay. See here, this n minus 2 is a constant. Take it out. So what we are getting here? Secant power n minus 2x into tan x minus integration of, just take out n minus 2 outside, n minus 2, take a big bracket, then integration of secant power n minus 2x into tan x into tan x, tan square x into dx as it is. Okay. So just here I have took out this term outside, and just I have multiplied tan x into tan x is tan square x secant power n minus 2x as it is. Okay. Now the basic knowledge of trigonometry here we have to use. What is that? You know already, I think. Secant square theta minus tan square theta is equal to 1. So secant square theta minus 1 is equal to tan square theta. Okay. So this tan square theta, I am converting in terms of secant square theta and minus 1. Okay. This is the conversion here. So what I am getting here, look at. So what we are getting, this term is as it is. In is equal to secant power n minus 2x into tan x minus n minus 2 integration of in the bracket integration of secant power n minus 2x. This tan square x I can write as secant square x minus 1 according to that. Secant square x minus 1 into dx, close the bracket. Okay. Just roughing that side. Okay. So now just simplifying, taking this term inside this term, and let's see what we are getting. I can write secant power n minus 2x into tan x minus n minus 2 in the bracket. Integration of secant square n minus 2x into secant square x is just secant power nx minus secant square x n minus 2 into x is just, you can write as it is, secant power n minus 2x into dx. Okay. Yeah. Just separate the term and take this term inside the bracket. So I can write in is equal to secant power n minus 2x into tan x minus n minus 2 integration of secant power nx dx minus into minus plus n minus 2 integration of secant power n minus 2x dx. Yeah, whole multiplication for the term is completed. Now, just this minus term I'm taking to LHS, or else we can substitute the respective values for this, and then we bring that term to this side. Look at here. Secant power n minus 2x into tan x minus n minus 2. Integration of secant power nx dx. I can write in. Yes, like previous only. In plus this particular term, this term, I can write as n minus 2 in minus 2. Okay. If here is n, here is n. Here is n minus 2, here also n minus 2. So according to that, I have written here n minus 2, in minus 2. Okay. Now bring this term to this side. Let's see what it becomes. in plus n minus 2 in is equal to secant power n minus 2x into 10x. Again, because this term, this complete term is here, what is left? Plus n minus 2 in minus 2. Okay, this we have got. Now observe the LHS. If I take in as common, okay, so what we are getting? In, if I take common, 1 plus n minus 2 is left here, and this term is as it is secant power n minus 2x into 10x plus n minus 2 into in minus 2. Okay, all the terms are as it is. So minus 2 plus 1 is minus 1. So this becomes what? in the bracket n minus 1 is equal to same terms secant power n minus 2x into 10x plus n minus 2 into in minus 2. Now, this term n minus 1 when comes to the right hand side, so we can write in is equal to secant power n minus 2x into 10x divided by n minus 1 plus n minus 2 by n minus 1, or is use just one bracket for these two terms, into in minus 2. This is the reduction form for the secant power nx into dx. Finally, we have got here. Okay. So just check from the beginning what is actually given to us and what we have told about the secant power nx into dx. Okay. Just observe from the beginning what we have done so far. Then we will move to the for the secant power 5x. Before that, odd and even condition we have to use. Okay. If it is okay for you, so we proceed further. If each and every step is understand by you. So we have to deduce next condition that we have to deduce is secant power 5x into dx that we need to deduce. Okay. Just I'm referring this. Very, very important. This particular reduction form I am writing once again here because we have to use it for the our next process. So just I'm writing here the solution is completed. Okay. What is in? We have got I, and that is integration of secant power nx dx, secant power n minus 2 x into 10x by n minus 1 plus n minus 2 by n minus 1 into in minus 2. Okay. See here, this particular reduction form, we have to check for the odd and even condition. So as usual, previous solutions, just here we are going to supposed to be for even condition and odd condition. For even, if you want, take n is equal to 2. Okay, the condition given is n greater than or equal to 2. So we can take just for even n is equal to 2. If n is equal to 2 means first two times we have to put here only 2 minus 2 I naught. So we have in is equal to integration of sine and secant, not sine, secant power nx dx. Okay. So for the first two times we have to use this condition only. Keep 2 here. 2 minus 2 is 0. That is I naught. I can write is equal to integration of secant power 0x into dx. Anything power 0 is 1. So integration of 1 into dx is nothing but x plus c. If you want c plus 1 to write, you can write. It's up to you. So we have got I naught is equal to x plus c for the even condition. Now, next we have to check for the odd also. Okay. So for odd, n is equal to 3. If you take what we are having in is equal to integration of secant power n x into dx. Now, n is equal to 3. Keep it here. 3 minus 2 is 1. So write here 1. So this is I1 is equal to integration of secant x into dx. What is integration of secant x into dx? Okay. So this I can write the formula directly. Integration of secant x into dx is log mod secant x plus 10x plus c. This is the formula for I1. So now we have got these two conditions for odd and for even. Okay. Now coming to the our main problem that we have to solve again. See from the first line, that is in is equal to integration of secant power nx dx till here, and one more solution. This all solution is the solution of only one problem. Okay, for 7 marks. For 7 marks. Now coming to the what they are asking in the next part of solution. They are asking just we have to deduce the value of integration of secant power 5x into dx. That is an odd number with the prime. Let's see what we can do. I5 is equal to integration of secant power 5x into dx. Only for the first odd condition, for even condition, you have to approach the way I have showed to you. In remaining all the cases, you have to use directly the formula. This formula only directly you have to use. Okay. You cannot substitute again here 5 minus 3 is 2 like that. You can't do. Okay. So look at here. See, observe. I5, I can write is equal to the value of n is 5. Secant power 5 minus 2 is 3x. So it is secant cube x into 10x divided by n minus 1. 5 minus 1 is 4. Plus n minus 2 by n minus 1. 5 minus 2 is 3. 5 minus 1 is 4. So it is nothing but 3 by 4. Okay. Then again in minus 2. That is I3. Okay. This is the reduction formula for reduction form for the first step. Again, here the value of n is 3. So same process we have to repeat, but with the change of the value. Now the value is not 5, it's 3 for n. So let's see what we are getting. Secant power 3x, that is secant cube x into 10x by 4 plus 3 by 4 in the bracket. This complete form we have to write there. Now n is 3. So secant power 3 minus 2 is 1. That is secant x into 10x in numerator. Secant x into 10x in numerator. N minus 2. 3 minus 2 is 1. No need to write. Move to the next step. 3 minus 1. Sorry, you need to write here 2. 3 minus 1 is 2 plus n minus 2. That is 3 minus 2 is 1. N minus 1. That is 3 minus 1 is 2. Here, in minus 3. 3 minus 2 is 1. It is take the form of as I1. Okay. So just take 3 by 4 inside this bracket and see what we are getting. Okay. So this you have to write secant power cube x into 10x by 4 plus 3 into secant x 10x 3 secant x into 10x by 4 to the 8 plus 3 1 the 3 1 the 3 by 4 to the 8 3 by 8 I1. What is I1 directly we have, that is log mod secant x plus 10x plus c. So on the place of I1 I can write log mod of secant x plus 10x plus c. Therefore, this is the value of I5, that is integration of secant power 5x into dx. Be careful for each and every step how we have got. So just check it once again and observe how we have got the values. So we can do for the week. I can give as homework the next form, but you just take it what we have done so far here. Okay. Very, very important. The similar problem I'm going to give as homework. See, when it's come to the part of integration, that is the part of calculus, each and every day, you must have to practice. See, in integration, we have so many formulas, so many concepts, and this all concepts are going to be useful in your engineering and graduation. So whenever you are learning, especially 2B and in 2B, if you're learning calculus part, that is integration, differential equation or definite integrals, so be careful and understand the concept clearly, then only you are able to proceed further. See here, only the half line is, one line is given to you, but the solution is, this is the second time I have written by roughing the board. Okay, so that much lengthy solutions are come. So practice properly, perfectly, and check yourself how you can represent yourself in a best way so that your success is comes to you. Okay, please check it once again. And then I will give you as one problem as homework. Then we will go to the next chapter important. Just I'm checking what I have to give you as homework. Some problem I'm giving as homework, you just practice. Okay. I'm going to rub this. These homework are as homework. This problem are as homework. Okay. Obtain the reduction formula. Reduction formula for In is equal to integration of cosecant n x dx, where n being a positive integer, a positive integer, and greater than or equal to 2, and hence deduce the value of integration of cosecant power phi x dx. Cosecant power phi x dx. This is the form that very, very important. Again, I'm telling you have to do. And with this problem, just one more problem I'm giving as homework that you have to do. Only one more problem. That is integration of, this is the second problem, a power x minus b power x by a power x into b power x into dx, where a should be greater than 0, comma, a must not equal to 1, and b should be greater than 0, comma, b must not be equal to 1 on R set of real numbers. Okay, these two problems you have to do by yourself. Before starting the integration chapter, I told you that that the first problem that we have solved, integration of 6x minus 5 in the bracket 6 minus 2x square plus 5 into d plus 6 into dx. That was the first problem, and similar problem I gave you as homework. Okay, and it was the first day for the integration. Then that was the first day for the integration. Now, then we have moved for the reduction formulas. In reduction formula, I told you sine cos, same concept with the changes, similar, little bit change according to the formula. Okay, that is the same concept. Tan cos, same concept. Secant, cosecant, same concept. You have to apply. Okay. So this, including this problem, damn sure one of the problem that we have solved, integration of 6x minus 5 in the bracket root over 6 minus 2x square plus 6 into dx. That problem and similar problem I gave as homework example problem. And this reduction formula, the problems which we have solved in the class and which I have assigned as homework. Damn sure this problem will come in your exams. Okay. So now uh, this is the first chapter of calculus that we have learned in 2B. Now moving to the next chapter, important problem. That is one of the LQ today we are going to do. Definite integrals. Which definite integral? Just we are going to choose the most important problem for the definite integrals in order to get the qualifying marks at least. Okay. So what we are having here, very important, and this is the problem of definite integrals. The name of the chapter is integration is completed, LAQs. This is definite integrals. Okay, 7th chapter of your 2B, and you will get one LAQ, one SAQ, and one VSAQ. Okay, let's see what we are having here. The most important problem, that is evaluate integral or integration 0 to 1 log 1 plus x by 1 plus x square into dx. Into dx. Okay. This is the most important problem that we have chosen here in order to practice and in order to get qualified. Evaluate integral 0 to 1 log mod 1 plus x by 1 plus x square into dx. Okay. See here, in definite integrals, find the region of bounded area. Okay. And for the odd and even concept, and then this concept. Especially most of the time, this problem came in exams, and this time also we are expecting it should to come as we are practicing. Okay. So let's see how to solve this particular problem of definite integrals. Solution, given that, okay, I is equal to 0 to 1 log of 1 plus x by 1 plus x square into dx. Okay. This we will solve by using the substitution. We will put some values for the x. We are assuming some functions value, that is let x is equal to tan theta. What I am assuming, whenever I am having x, I can use tan theta as it is I am assuming. So here differentiate with respect to theta. So what we are getting, dx is equal to d by dx of tan x is what? D by dx of tan x is equal to secant square x. Okay. So here d by dx of tan x is tan theta is secant square theta into d theta, as we are differentiating with respect to theta. So this is the value for dx. Okay. So just make a bracket for it, a box, not bracket. Okay. Next, here we are having two limits, lower limit as well as upper limit. Just we change this limit to some other values. That is, let's see what happened. LL means lower limit at x is equal to 0. On the place of this x, I can write tan theta. Tan theta is equal to 0. We know that. So I can write theta is equal to directly 0. No change in lower limit. Okay. Let's see for upper limit at x is equal to 1. This x I can write tan theta. This one I can write tan pi by 4. Tan get cancelled. So theta is equal to pi by 4. This is upper limit. Okay. So lower limit 0, upper limit is pi by 4 we have got here. Okay. So just now coming to the our main problem with the substitution. Now we will write. So I can write integration of lower limit is 0, upper limit is pi by 4. Just see these steps. Log 1 plus tan theta by 1 plus x square, that is 1 plus tan square theta. 1 plus tan square theta into dx. On the place of dx, I can write secant square theta d theta. Secant square theta d theta. Okay. Again, here, the basic trigonometric identity we have to use and change this form to secant. How? Look at here. Secant square theta minus tan square theta is equal to 1. I can write secant square theta is equal to 1 plus tan square theta. Okay. So on the place of 1 plus tan square theta, I can write secant square theta. So just write here integration of 0 to pi by 4 log 1 plus tan theta as it is divided by 1 plus tan square theta. I can write secant square theta. See the right hand side of simplification, that side, into secant square theta into d theta. This and this get cancelled. So finally, what we are getting? I is equal to 0 to pi by 4 log 1 plus tan theta into d theta. Log in the bracket 1 plus tan theta into d theta. See here, this is a number we can't do. Keep it as it is only. This is 0 log integration 0 to pi by 4 log tan theta into d theta. Just I am using a small concept of definite integral, that is integration of 0 to a f of what I can say x into dx. I can write integration 0 to a f of a minus x into dx. See here, pi by 4 means this tan theta, you can write tan of pi by 4 minus theta. Okay, that is a basic thing. Just I have written there. Okay, so just all the remaining things as it is. So integration of 0 to pi by 4 log 1 plus tan theta, I can write pi by 4 minus theta. Okay, see the bracket carefully how I am using. Okay, Just I have changed tan of f of x as f of a minus x. This is a. Okay. Now we know that tan pi by 4, that is 45 degrees 1. So this is in the form of tan of a minus b. What is the formula of tan of a minus b? Tan of a minus b is equal to tan a minus tan b divided by 1 plus tan a into tan b. This is the formula that we have to apply here. One more step. This tan pi by 4 is nothing but tan 45 degree, that is 1. So whenever we are having to use tan a, means directly I'm writing 1. Okay. So just you note down with the pencil, tan pi by 4 is 1 for us. Okay. So this I can write integration of 0 to pi by 4 log as it is, 1 as it is, tan according to tan a minus b, tan a, that is 1 minus tan b, that is tan theta, divided by 1 plus tan A into tan B. Tan A is 1 into tan B is tan theta as it is. So, and d theta, keep it as it is, and here also d theta. Take the LCM, 1 plus tan theta into 1, integration of 0 to pi by 4 log 1 plus tan theta into 1, 1 plus tan theta plus 1 minus tan theta as it is, divided by 1 plus tan theta into d theta. Minus tan theta plus tan theta get cancelled. 1 plus 1 is 2. 2 by 1 plus tan theta. So this you can write integration of 0 to pi by 4 log 2 by 1 plus tan theta into d theta. Okay. I'm going to ref that all formulas right hand side in order to continue the solution. So this is so what, see here, the basic knowledge of logarithm I'm using, log a by b. I can write log a minus log b. Okay. Log a by b, I can write log a minus log b, remaining integration as it is, d theta as it is. Okay. So what I'm getting, this you can write here in LHS we are having I. Okay. Integration of 0 to pi by 4 log a, that is log 2 into d theta minus log b. Just separating integration pi by 4 log 1 plus tan theta into d theta. See here, this particular step, zero to pi by 4, 1 plus tan theta into d theta. Okay. 1 plus tan theta into d theta, you can write as I. Okay, you can write there as I. Instead of writing 0 to pi by 4 log 1 plus tan theta into d theta, I can directly use as I here. So this become I is equal to integration of 0 to pi by 4. Take log 2 outside, it's of constant form, log 2, 0 to pi by 4 into d theta, 1 into d theta, just d theta minus I. Okay. Take this minus to that side. So it becomes I plus I plus I is equal to log 2. Integration of 1 into theta is theta only. Limits 0 to pi by 2. Okay. So here I plus I, 2I is equal to log 2 upper limit minus lower limit. That is, our limit is pi by 4, not pi by 2. Okay, pi by 4. Upper limit minus lower limit is 0. No need to write. Keep it as it is. Okay. So now I is equal to, I can write pi by 2 into 4 into log 2. This 2 here. So I is equal to pi by 8 log 2. Therefore, I is equal to pi by 8 log 2 is our final answer. Therefore, the integration of 0 to 1 log of 1 plus x divided by 1 plus x square into dx, how the process I have used to solve and to get the solution. Okay, so observe each and every step in order to represent this problem in an accurate manner. Practice. Okay, just check it